Hello and welcome back to Eurocode2 class. Let's try to continue the chapter number 1. I think last time we started this point number 4, material. We talked a little bit about the exposition of concrete of structure, and we determined different type of exposition classes. Okay, so today we are going to continue with the same point number 4, trying to see how to use these exposition classes to determine the required strength of concrete, and maybe next time we will try to determine the minimum minimum cover for the concrete. Okay, so that means today also we are going to stay here, the point number 4. Okay. So part 2, point number 4, part 2, 1-4. So if you didn't watch or you didn't follow the previous video, I recommend you watch it first before continuing with this one, because they are related. Last time we talked about this exposure classes. These are classes determined due to the different type of exposition of the building, which is the environmental effect on the building, on the structure. Okay, so we did determine several classes depending on the environment where the building is located. Okay, so the same building can be subjected to different type of environment. That means different part of same building can have different expositions. Okay, anyway, we did all this last time, and we have to use it. We have to know how to use it to determine the concrete strength. Okay, and maybe later we can determine the structural class and then the concrete cover. Okay, so if you go in Eurocode2, the Annex E, informative Annex E, or the EN 206 Annex F, you will find different requirement or minimum strength class of concrete depending on the exposure of the building. The different classes of exposition we talked about last time, these classes are used to determine the minimum strength of concrete. Okay, makes sense, right? I think it makes sense. So here is where you can find this kind of information. So if you remember, last time we talked about this kind of exposure classes, X0, XC1, XC2, XC3, all these we talked about last time. And X is standing for, sometimes I'm talking in French. X is standing for exposure. C is the method. Okay, we talk about what is the meaning of these letters last time. Okay, C is standing for carbonation. Okay. Okay. Corrosion due to carbonation. And S here is standing for seawater, sea. Okay. So these are for the reinforcement, steel reinforcement, and these are for the concrete itself. Okay. Anyway, we did all these classes in the previous video. Please go back there if you forgot and try to remember what is the meaning of each of them. Okay. But what we are trying to do here is we have to find what is the minimum strength of the concrete for each class of exposition. Okay. So this table from the EN 206 Annex F is giving us some recommendation. Okay. This line, I think this first line up to here we did last time. So this line, I will call this first line because this is the new line. From here, the new part is starting from here. All this is not new. So if we consider this line is giving us the water cement ratio, the maximum water cement ratio for each class, each exposure class. Okay. It means if you have exposure class XC1, the maximum water cement ratio you should have is 0.65. Okay. So all this line is giving us that information. Why is it that? Because this ratio, this water cement ratio is influencing the strength of the concrete. Okay. So if you respect this ratio, you have solved half of the problem for getting the required strength of the concrete. Okay. And next, this line is giving us the minimum strength class. Okay. C for X0, C 12, 15, C 20, 25, C 25, 30. If you don't understand what is this class is, this strength, don't worry, I will explain this soon enough. But remember that C is for concrete. And 20, 25, for example, is just the strength in the compression in megapascal. Okay. So, but why 30, for example, and 35, 37? Okay. So anyway, these are the strength, minimum strength of concrete for each class of exposition, each exposure class. Okay. And then we have next, sorry, the minimum cement content. Okay. The amount of cement you need to have. So you have here 260. It means kilogram per cubic meter. Okay. It means in 1 cubic meter of concrete, you should have 260 kilogram of cement for this class. Okay. For this class, XC2, you should have 280 kilogram per cubic meter of concrete. In 1 cubic meter of concrete, you should have at least, because here it's saying minimum, so at least 280 kilogram of cement. Okay. So on each class of exposition has the minimum amount of cement. And for the case of this kind of freeze and thaw attack, it means the XF or for the protection against freeze and thaw, you have to add some air in your concrete, okay? And for the minimum air content in percentage, in that case is we have this value. And this here you don't need. So XF2 to XF4, these are the value of the in percentage the air you need in your concrete. Okay. So this value 444, it is written here. The concrete is not air untrained, where performance of concrete should be tested according to an appropriate test method in comparison with concrete for which 3 and 4 resistance for the relevant exposition class is proved. Okay. And you have also other requirements. It is not all, okay? Other requirement for these classes, XF classes, you have also a the aggregate, okay? The aggregate you need to mix with the cement and water to obtain concrete. These aggregates should be in accordance with this code and should have sufficient freeze and thaw resistance. Okay. And for the case of chemical protection against chemical attack, in this XA2 and 3, you should have sulfate resisting cement. It means you cannot use any cement. And there is precision here when this ion, the sulfide ion, SO form 2 minus, lead to exposure class XA2 and XA3. Okay, it is essential to use sulfate resisting cement, where cement is classified with respect to sulfate resistance. So anyway, in these cases, you cannot use any cement. If you have chemical, you have risk of chemical attack. You have to be careful the type of cement you are using. Okay, I hope this table is well understood. It's not really complicated. The table is not really difficult to understand. I think it's not difficult to understand. Okay, if you did understand what we talked about last time, the different classes of exposition, then remember that for each class of exposition, there are some requirements for minimum water cement ratio, minimum strength of concrete, and this can be tested, and minimum amount of cement in kilogram, and air content, and some other requirement. This is what it means. So this table, you should know it, and I will explain the meaning of this soon. But one thing very, very important about this table is that this table is designed for this assumption. 50 years, okay? Design work life of structure for 50 years. But remember, some structures are designed for less than 50 years, but some are designed for more than 50 years. For example, 100 years, okay? In that case, you will need some modification, and we will see how to modify and adapt it. But no big deal. It will be just do +1 or +2. For example, if you are here in case of 50 year, and then you want to design for 100 year, maybe you change to come here, something like that. But you remember that this table is for this kind of condition. Design working life, 50 years, and the normal weight of aggregate with Dmax, the maximum diameter of the aggregate, in the range of 20 to 30 millimeters, and the cement of the strength class 32.5. Okay, this is also another story because there are different category of cement. Okay, but anyway, when this condition when this condition change, these condition will change in different project, and according to the condition, you need to bring some modification. Okay, and we will see this. Okay, I think it clear. I will just try to explain the meaning of this. Okay, the minimum strength class for the concrete C2025, C2530. What is the meaning of this? Okay, I will take example, this notation, for example, C2530, C3037. It refers to concrete strength class defined in this European norm. Okay, and this, as a reminder, is the European standard for concrete specification. Okay, not for design. So this 25, 30, 30, 37, this, it indicated the characteristic compressive strength of concrete, not traction, okay, compression. And it is measured in megapascal. So these are some examples. You see, when you are doing a project, you have to take some sample or from the concrete you are using to build and do this kind of samples. Okay, please note this one, ignore this. Okay, it is just this one. You can see here is cylindrical, or you can do this type cubic one. Okay, and you let it dry 28 days. Okay, because 28 days is when the concrete reach its maximum strength. And then after that, you go to test it, compression. You go to test it and find out the compressive strength of the concrete. Okay, something like this. You can see this is cylindrical sample, which is this one. Okay, and please ignore this. This is another story, something else. We will talk about this later. But I'm talking about this cylindrical shape sample, which is exactly something like this. It will give us something like this. The sample will be obtained after 28 days. We can then make compression test and find out the compressive strength of this concrete. This is cylindrical one, and this one cubic. Okay, cylinder and cube. Okay, so what you are seeing here, 25 and 30, 30 and 70, 37. If we want to break down the notification, C, okay, X is for the first one, for example, 25 here, 30. Y is for the last one, 30, 37. Normally, if someone who is understanding concrete, this will be a little bit boring, but I want to make sure that everyone understand what I am talking about. C is standing for concrete. C is X, the first one, the first number, represent the characteristic compressive strength of cylindrical specimen. This specimen. okay, and the dimension are here, and test it after 28 days. 28 days, okay. And the last one, Y, is representing characteristic compressive strength of cubic specimen with this dimension. At 28 days age, okay. So you now understand this notation. 25 then means the strength obtained from this test after 28 days. 30 means the strength obtained from this, and they are both in megapascal, okay. Compression, I think this also is clear now. So we can go to talk about cover, concrete cover, because everything we are doing since the previous video to now is just about how to obtain the cover. Okay, what is concrete cover? The definition is here. See, this is the reinforcement. Supposing this is a beam or maybe column, okay, and you have this reinforcement, steel reinforcement, okay. This is your concrete reinforcement bars. So the cover is this distance from this, not the center, okay, from the body of this bar to the surface of this beam or element of the structure. This is what we are calling cover. So what is this dimension? What is this distance? This is what we are trying to find out so far, actually. Everything we have done in this point 4, section 4 of this chapter is about to obtain this. First, we obtain this exposure classes, and from these exposure classes, we saw how to obtain the strength of the minimum strength of concrete, and then we will later find structural classes, which is different from the concrete strength, okay? It is not same. And then we will end up to find the concrete cover, this cover. So according to Eurocode2, chapter 4, the design of the minimum concrete cover requires some steps, okay? Because this cover is important because it helps to protect this steel bar reinforcement for corrosion, and also it helps to for the bond between this steel bar and concrete, so that it can be like work as unit. Concrete and steel should work together, okay. The steel should not move inside the concrete. That also is important. So there are some steps to follow and to find the minimum value of this cover, okay. First step is to identify the exposure classes, and this is what we did in the previous video. Remember, different type of exposition of the structure. This is the first step, and we have determined many exposure classes, okay. Next step is to identify minimum strength class for each exposure class. And this is what we did right now. The minimum strength of the concrete. You see it in the table, the previous slide, table is showing for each exposure class, there is a minimum strength. Okay, that is the second step. Okay, and step number 3 is to find out the minimum cover for both durability, which is written, if you see this, it means durability, and the bond B. Okay, I was saying that we need a good bond between the concrete and the steel bar reinforcement. Okay, so there is a minimum cover for durability. If you want the durability of the steel bar, there is a minimum. Okay, you need to adapt the minimum cover you need to adapt, and also the bond between the concrete and the steel bar. Also, if you want a good bond, you need a minimum also cover. So this minimum cover is C min, and it's obtained by using this maximum between these C min B. C min B is the bond, B for bond, okay? C min D for durability, the minimum cover for durability. This is the minimum cover required for the good bond. And this one is the minimum cover required for the durability. And on this, you can add this one or reduce this one or this one. And this is 10 millimeter. So please tell me, you can see that we have three values. We need to choose the maximum of this. You have this one, C minimum for the bond, and you have this, okay? This is one value. And you have 10 millimeter. You can see that they are separated with semicolon. This. So you have the maximum between this one and this value and 10 millimeter is C minimum. It means C minimum cannot be less than 10 millimeter. Actually, this is the meaning. So this is the meaning of this. C minimum B is minimum cover due to the bond requirement. Okay. C minimum D, this one is the minimum cover due to the environmental condition. This is for the durability, it is here. Okay. And this one here is additive safety element. Okay. You just add something plus something for safety. Okay. And this one is the reduction actually for this. This one was added for safety, and this one is reduction due to the minimum cover for use of stainless steel. So if you are using this type of steel, you can reduce this one, a value. And you reduce this one also in case, just in case you have used additional protection. For example, if you are using some painting on the concrete, you have using some protection on the concrete. For example, water cannot enter, some chemical agent cannot enter, penetrate the concrete. Then you can reduce just minimum. Okay, so what is the minimum? What are the value for these element, all of them? Okay, because we need C minimum. So what is the value of this, or this one, this one, and this one, and this one? Okay, these are what we need to determine for the next. Okay, so according to Eurocode, these three, 1, 2, 3, these are here, this one, and this one. Okay, these three, the value of these, if you want to find for each country, you need to go to the national index of that country. The Eurocode itself is recommending this value to be 0 without further specification. Just take it 0. But it depends on each country in European country, because that make also difference in Eurocode in some countries, in European countries. Okay, but the Eurocode is recommending to take this, just ignore all this. This 0, this is 0, this is 0. But if you go to one country to another, you can find some difference. For example, if you go in UK, maybe they will not take this 0. UK, Germany, Italy, France, you may have some difference. Spain, okay? But the recommended value is 0. So based on that, I will put this here. These three are 0. So in our case, maybe we can reduce this equation to just this. In our example, don't forget that we are also doing one example step by step, trying to solve one example work project. So we will just consider reduce this equation to this one. Okay, so it will be, this one is still here, we cannot ignore this, and this one also is here, and this one we ignored it, this one also was ignored, but we kept this one. And if you remember, this one is because of additional protection on the concrete. This is what we said. So this equation reduced to this one easily. And as I said, this one, we do minus this one. This is only in case we take account, we use some cover, okay, due to the concrete surface protection. If you are protecting the surface of the concrete, for example, for painting or something else, then you can reduce just a little bit the cover by this amount. But remember that Eurocode is recommending to use 0 for this one, this value. You don't have to reduce. Even if you are painting, it will just bring more protection, okay? So let's keep this here. So remember, this is the minimum C, minimum cover due to the bound and to the durability, okay? So it should be the maximum between this value and this value and 10 millimeter. It means if this one is less, this one and this one are less than 10 millimeter, you still have to keep 10 millimeter. Okay, but this, if this one is higher than 10 millimeter, you have to consider it. And if this one also is higher to 10 than 10 millimeter, you have to consider whichever is higher, okay, between this one and 10 millimeter will be the C minimum, okay? But it is not finished. The C minimum is not the cover yet. You need still more. Step number 4. Step number 4 is to identify the nominal reinforcement cover, concrete cover, C nominal, okay? This is C minimum, but there is also C nominal. This C nominal is explained here. The C nominal is maximum between C minimum, the C min, see, C min plus something. This is allowance in the design for derivation. This delta C, is similar to this one, okay? You can just say delta C div or delta C, shortly delta C. So this one is added in case of some error, in human error or something happen. That's why it's saying designed for deviation, sorry. So it means if you want the C nominal reinforcement, you take the C minimum you calculated here plus delta C. The value of delta C is between 0 and 10, okay? And you compare this value with 20 millimeter. If this value C minimum plus delta C is larger than 20, then you consider it as C nominal. But if this is smaller than 20, then you have to consider 20 as the C nominal. So it means C nominal is the maximum between this one and 20. Okay? It means the C nominal cannot be less than 20. There is no way that this C nominal can be less than 20. But what is C nominal actually? Physically, what is the physical meaning of that? We will explain this from here. Okay? This is the C nominal. Okay? From here, this to here, this surface. If you check this, if you look at this, for example, this arrow, you see it is from this steel bar to the surface. Okay? But this is actually, in our case here, it is from here to here. In actual work, you need another transversal bar, this to cover these 4 steel bars, okay? And this is what is here. It means if you have this, let's suppose that this is a beam, sectional, and these are the reinforcement, the long reinforcement bars, the dots you are seeing here, okay? And you have this. Let's zoom up only this part, okay? Zoom of this part is here. It means this dot and this dot are this one and this one, okay? So if we come here, what we are calling C nominal is from here to here, to the surface of the first steel you will reach, okay? Not this one, not these long bars. Okay. This is the C nominal. This is actually what you should call cover. So the other definition, you can see D prime. D prime is from the center of this to the surface, which is here. You can see from the center. So for that, you need to add the diameter of this bar, this steel, which is here, and half of diameter, see, of the long bar. Okay. So anyway, you have C minimum here and C nominal here. So C minimum, C nominal, and C nominal is explained here. What is C nominal? So beside bond and steel corrosion protection, it means beside bond and durability, the C nominal here, you also sometimes have to add the resistance to fire. But in our case here, we will not consider that. But resistance to fire will require you to add something on this for more protection of the steel bar. Okay. But anyway, this DC, as I was saying, it range between 0 to 10 millimeter. Okay. So I think we will stop around here. So remember that for now, we are just giving these, okay, how to obtain C minimum, and from C minimum, how to obtain the C nominal. C nominal is explained here. Okay. So we have talked about the minimum strength of concrete. Minimum strength of concrete, we talk about it. You have to choose the minimum strength based on the exposition, the exposure classes. And you will get the minimum water cement ratio, minimum strength, and minimum cement content, and air, and so on. This is for 50 years design working life. And we explain what is the meaning of this. Okay, the strength. And we also talk about the different steps you need to follow to estimate the minimum cover for concrete. Step 1, finding the exposure classes. Step 2, finding the minimum strength of concrete. Step 3, calculating the C minimum. And in this C minimum, you need to talk about this minimum cover for bond and durability. These are considered to be these last 3 around 0. Step 4, if you obtain C minimum, okay, simplified C minimum is this. If you have C minimum, you can now go for C nominal, and C nominal is estimated, explained here. Okay, this is summary of what we did, what we talk about today. So next time, we are going to find out now how to obtain the value of this, because right now we are just dealing with formula. Okay, what is the value of C minimum depending of each class, exposure class? What is the value of this C minimum B and C minimum for durability, and C nominal? We need the values depending on each class of exposition, and we will apply it in our example, the building we are still trying to design. So as you can see, everything is depending on the environment, the exposition, how the environment affect the design. You can see it here very clearly. Okay, so we will stop here for today. Thank you very much for your time, and see you next time. Thank you.